Algebra 1, Day 78. So today we're going to be continuing our study of exponential regression, remembering that this is not something you can usually do by hand. Whenever we have a real life circumstance, such as we're collecting data on populations, virus spread, bacteria growth, anything like that, that data is never going to be exactly exponential. It is going to be maybe a 99% match, but never exactly. So we always need to utilize a calculator in order to do these. So let's go ahead and jump in. So, first problem. The table shows the average salary of baseball players since 1984, or x equals 0. So I'm going to go ahead and I'm going to put my x's over here. And the reason why I'm doing that is we always want to start, for these particular problems, with our initial time, or whatever our x unit is, as 0, our y-intercept. Using the data, generate the exponential regression with both the coefficients and base rounded to the nearest hundredth. Two decimal places. Okay. So let us go ahead and we are going to type these values in. So first thing over here on my calculator is I'm going to go ahead and go to my home screen. I'm going to open up a spreadsheet. For this one, I'm going to call this my x's from example number 1 and my y's from example number 1. I'm going to go ahead and type in my x's, 0 all the way up to 9. All right, so I have all my x's inputted. Let me go ahead and put in my y values. Now, here they had our numbers in kind of a reduced format. They did it in thousands of dollars. Okay. So I'm going to type them in exactly as they are, but I just want you to remember that this is in thousands. This is not $290. Okay. All right. So I have those values inputted now. Now I'm going to go ahead and run my regression. Up to this point, it is exactly the same for a line, quadratic, anything you're ever going to run a regression on this calculator, exactly the same process. The only difference is that when I go over here to stat calculations, I have to pick which one of these guys I want. We are focusing today on exponential regression, so I'm going to go ahead and select my x values, y values. I'm going to call this my function from example number 1, so that way just in case I need to call up data at a later point. And I'm going to go ahead and click OK. Now, here is the equation that they gave me. So y equals 276.67 times 1.21 to the power of x. It is a 99% fit. So that means that these data points are going to be really close to this exact equation. All right. So again, my function is going to be y equals 276.67 times 1.21 to the power of x. So I got that written down. Here they want me to find how much a baseball player would be making in 1997. Now, I could go ahead and I could store this again as the shortened form, or I can call it up with the actual exact equation. Here they're asking me to round, okay? So I'm going to have to use this equation. So what I'm going to do is, first thing, I want to go ahead and head over to a calculator page. I am going to go ahead and type in my equation. So f example, and I'll say the shortened form for number 1 of x. Whoops, hold on. Let me go ahead and type in my equation. 7. All right, so I have the equation typed in. I'm going to go ahead and store it by hitting Control VAR, and it's going to store it under whatever name I put. So now it's stored. I could have also have just graphed this and looked at the table, or come back here to get the values. There's lots of different ways to do this. So they want to know what is the approximate baseball player would earn in 1997. 1997. Well, we didn't demarcate our years for that, so let's go ahead and do that. 94, 5, 6, 7. That'd be 10, 11, 12, 13. I need it whenever x equals 13. All right. So I'm going to say, all right, I need this function that I just created. Plug in 13 for me. And they will be making approximately 3.2974 million. Now, if I was to convert that, that's what that would look like. Remembering that we have to multiply this times 1,000 in order to get the correct number because these values were given in thousands. All right, 2005, so 98, 99, 2000, 1, 2, 3, 4, 5. And here I'll say 14, 15, 16, 17, 18, 19, 20, 21. So for this guy, I need x equals 21. I'm going to head back over to my calculator. And that's quite a bit of money. So here they would earn 151. All right, hold on 1 second. Let's see here. All right. So here it would be 15,151,500 approximately. We've got to multiply it times 1,000, and I'm just going to verify. So it gives me a really long number, and it's telling me it's got to move 7 decimal places, but that's all right. So let's go ahead and take a look at the very next question. What year would be the baseball player make about $2 million? So $2 million is going to be 2,000, right? So this is where y equals 2,000. Now, there's a lot of different ways that I could do this. I could just plug this in and let it solve itself. I could do a lot of things, but I think the simplest thing for us to do in order to find that value would just be to look at the table. So let's go ahead and we'll graph out that function. And I'm going to go ahead and look at my table. I'm looking for approximately 2,000. So it looks like it's going to be somewhere in between 10 and 11. But for the purposes of this, I would say 11 because that's already over 2 million. So my correct answer would be 11 years. All right, let's take a look at the next one. A student uses data to find the exponential regression function y equals 18.21 multiplied times 1.29 to the power of x to model the population of a herd of bighorn sheep y for each year x after the initial count. So here they're asking me a couple of questions about this equation. So first thing I'm going to do is I'm going to go ahead and I'm going to graph this equation. So I'm going to go ahead and call this FEX2. And I'm going to go ahead and plug in this equation. I'm showing you the other way of how to do this. All right, so I got it. It looks pretty exponential to me right now. And they're asking me how many sheep will there be after 3 years. Let's go ahead and take a look at the table. I'm looking for x equals 3 years. Approximately 39. Okay, pretty simple. What is the best estimate of the time in years for the population to reach 65? So let's look for 65 over here. Approximately 5 years. How many years will it take for the population to be at least 500 sheep? So we're looking for any number over 500. So it looks like in order to cross over into that 500 category, we're going to have to get to the 14th year. So approximately 14 years. How about how many sheep will there be after a decade? A decade means 10 years. So let's go back and look. There'll be approximately 232 sheep. And that is everything for today. So remember, if you are looking for an X, you can plug it in. You can also look at the table. So you can plug it in at the main calculator stream to call up a very specific X. You can also look at the table. However, for a Y value, it's easier to look at the table and estimate, okay? So I want you guys to go ahead and get started on your example question, and I will see you next time. Have a good rest of your day.